Alright, our client wishes to construct one Walmart, one fast food restaurant, and one community center with an outdoor swimming pool. In addition to the main site features, our client also wishes to design a right turn lane off of Holland Road while incorporating 3 existing entrances off Buckner Boulevard, while ensuring adequate traffic flow and ample parking on the site. The site is located at 3201 Holland Road, Virginia Beach, Virginia, and is planned on section areas. As outlined by the red box, the plot of land is 11.71 acres of wooded area under B2 zoning. The project adheres to the standards for a community business district. Some challenges on the site include wetlands, excessively flat terrain, and a flood zone in the western part of the site. The parcel is located at the intersection of Holland Road and Buckner Boulevard. Holland Road has a higher volume of traffic, while Buckner connects Holland to surrounding neighborhoods, and 4 access points will be incorporated into the site. All wet utilities, including tie-in locations, exist in the rights-of-way adjacent to the site. In addition to wet utilities, electricity, natural gas, and telephone lines are existing bordering the site. All wetlands have recently been permitted by the U.S. Army Corps of Engineers. Other challenges remain, such as clay soils, flood zones, and normal slopes, and proper design techniques must be utilized to avoid future problems. Our 2 conceptual layouts are similar due to site constraints, with the main difference being the placement of the stormwater management pond. This design was determined to be insufficient because the site slopes east to west. With the help of our mentors, we determined that our second layout would better satisfy our client's goals. Walmart is located centrally adjacent to the fast food restaurant fronting Holland Road. The community center is located on the western portion of the site, with a pool and a basketball court protected behind. The stormwater management pond is proposed for the middle of the site to collect maximum runoff, and additional stormwater management practices have been proposed along the west boundary to exist in the flood zone.
Let's talk a little bit about the grading of the site. Here's the existing grading, and to highlight the fact that the site is excessively flat, in the northeast it's about 12-foot elevation, in the southwest it's about 5 or 6 feet elevation, and there's like 1,200 feet in between those 2 points. There's 2 ditches that run down the site this way, so there's about 10 feet about the actual grading of the site. Here's the proposed grading. These are half-foot minor contours, 1-foot major contours. As you can see, it's pretty flat. It was a challenge for the pipe systems especially, and also drainage, trying to get water to actually flow on the site considering it's so flat. And here's our cut and fill. We had a net of about 5,000 cubic yards. And we're going to talk about the road design a little bit. Here's the 3 or 4 major drive aisles of our site. There's one entrance here, there's the right end in the top right, and then there's another entrance here. And the main drive aisle that we ended up doing the cross section for is the one highlighted here. And so we just sloped it away from the building at 2% in order to promote drainage away from the building and into the inlets. And this is just the road profile. And as you can see, it's extremely flat. It doesn't change much elevations.
So talk about how we designed the site for to handle stormwater. So we start off with pre-flow calculation. Number 1, this is the time of concentration, the flow path. Number 1 is overland flow, number 2 is shallow concentrated, and number 3 is the channel flow, which you talked about, the huge ditch. And we came up with a flow of 16.6 cubic feet per second. For post-flow calculation, we divided the site into different inlet areas and used rational method to find the post-flow. And as you can see, this is the Excel file, and we summed up all the flows. These are the inlet areas. since the site was really flat, it was really difficult to figure out time of concentration and flow paths. And we kept on changing our inlet areas and used like trial and error method to get it. But I guess we did. But these are the red spots indicate the drains, the inlets that constitutes these inlet areas. In this, I want to emphasize that we divided our site into 3 segments. The first flow path was the one handling the community center. The second flow path was handling the area behind the Walmart. And the third flow path was handling the area in front of it. And these are the flow paths. Now, I want to propose 3 bioretention BMPs for the site. We didn't grade the site to handle this bioretention, but it's just something, an idea we could put forward. And if we do that and we add stormwater and the green area behind the Walmart and make those as conservation easements, we could save a lot of money on real estate taxes. That's the positioning of our detention basin. This is not the site, but basically our detention basin, we calculated that our required size should be about 1.82 acre feet, and we have a detention basin of 2.3 acres feet. The detention basin is about 250 feet long and 9 feet wide. And as you can see, this is not to scale, it's just a screenshot. But as you can see from the cross section, about the average depth of the detention pond is like 4 feet.
And now we're going to talk about the utilities on site. This is the potable water layout. There's actually 2 separate systems servicing the western parcel of the community center and the eastern parcel of the Walmart and restaurant. And the western parcel will tie into the location of Bucket Boulevard and the eastern to Holland. To calculate water flow, this equation was used for the Walmart. It was found that 3,000 gallons per minute would be required, and since one hydrant can produce about 1,000 gallons per minute, we needed 3 hydrants to. The sanitary sewer layout was similar to the potable water in that there was one system for the western parcel and one system for the eastern parcel, tying into spots on Buckner and Holland River Stem. Maintenance equation was used to size the pipes for the sanitary sewer layout, and all of our pipes were found to be less than 8 inches, so they were sized up to this minimum size of 8 inches PVC pipe. And for the erosion sediment control in phase 1, construction entrances, diversion dikes, sediment basement, and sediment traps, and several types of inlet protection were all used. The 2 construction entrances were right here on the southern boundary and on the northeast corner there, and both of these locations will be used as permanent entrances upon the project's completion. And diversion dikes are going to be used to carry the water into these 2 sediment traps as well as the sediment basin. With inlet protection on these inlets off-site that might be affected by construction, but still kind of surrounding the site. And the majority of the features from phase 1 will be carried over to phase 2 with the exception of the diversion dikes and one of our sediment traps. This sediment trap was no longer needed because it's going to be a paved area and there's an inlet that can transport that water to a sediment basin. And the diversion dikes are no longer needed because since the site is paved, the curb and gutter as well as our inlets will take the water to the sediment basin. And there's going to be permanent seating up here in this green area for future use. Final cost estimate, we had about $2.9 million. And for value engineering, we thought that two ways we can reduce our costs would be to reduce parking to just meet the bare minimum, or we could take a better, more direct route with our lake utilities. Does anybody have any questions?
What was the most difficult part of the project?
I think it's definitely like the flatness of the site because it posed issues in pretty much every aspect of the project. From the grading to the utilities and I mean just about everything was an issue. So
Yeah, the pipe design.
yeah. It's hard to fit all the pipes in about 7 feet.